Hello viewers, welcome to Diagnostics, Dio here. Today we have a 2009 Honda Pilot with a 3.5 liter. The customer complaint on this vehicle is the battery light remains on while the engine is running. The customer also stated that there is a message on the dash that says check charging system. So the first thing we're going to do is we're going to confirm the customer's complaint. After confirming the customer's complaint, we're going to connect a scan tool to the vehicle to see what kind of trouble codes we have in the engine computer. After we retrieve the trouble code, then we will know what directions we're going to go so we can fix whatever that's causing the battery light to remain on while the engine is running. So now let's go inside the vehicle and confirm the customer's complaint. Alright, so I'm going to start the engine so we can confirm the customer's complaint. So right there, as you can hear, the engine is running and the battery light remained on, and there's a message on this dash display that says check charging system. Okay, so customer's complaint confirmed. So we have confirmed that the battery light remains on and there's a message that says check charging system. So I'm going to turn off the engine so we can connect a scan tool to the vehicle to see if we have any trouble codes in the engine computer. After checking the trouble codes, then we will talk about what directions we're gonna go so we can fix whatever that's causing this battery light to remain on while the engine is running. So now I'm gonna turn off the engine. So I will get the scan tool connected and then I'll bring you guys back up. So we have some catalytic converter trouble codes. P0420. So we are not here to worry about these catalytic converter codes. We are here to fix this P0562 charging system low voltage. Okay, this is what we have to fix. So I will notify the customer about this P0420 and P0430 trouble codes, and if he wants us to go ahead and fix these also, we will probably make a video with this, about these two trouble codes. But for now, we are focusing on this charging system low voltage trouble code. Okay, and this charging system voltage low trouble code is typically caused by a defective alternator or a problem in the wiring between the alternator and the battery, or the problem between the computer, the ECM, and the alternator, because the computer controls this alternator. So the computer tells the alternator when to charge the battery or when to stop charging the battery. So let's click on this diagnose button just to see if there's any TSBs about this trouble code. As you can see, there are a bunch of them. There are like 10 TSBs about this trouble code. So that's good to know. Let's click on it before we go through our top repairs. Let's click on these TSBs and see what we have. So I'm kind of just gonna read through these really fast. So this one says AC problem or a dead battery, check the compressor clutch relay. Okay, so a compressor clutch relay, I guess, can get stuck and then drain the battery over time. Okay, so the battery is not draining on this one. The problem is the light that's remaining on with the engine running. Okay, so we got some tests to do here. So they're doing a current measurement at the alternator. Okay, so anyways, it's good to know about all these TSBs. We can go through all of them and read every single one, but I'm not going to do that. We're going to keep this in the back of our minds, okay? We're going to check the obvious things first, let's go to the alternator and check for battery. They have to be battery positive at the B positive terminal of the alternator. And then there should also be 2 more wires at the alternator connector that should have power with the key on, okay? And then we will check the other wires that come from the computer. If all the wires check out okay, the problem would just be the alternator. So let's back out of here. And when you look at the top repairs with this trouble code, this P0562, so what has fixed this problem the most has been an alternator. Okay, replace alternator, replace battery, clean battery cable, battery cable terminal, or reprogram PCM. So our problem will most likely be a defective alternator. Okay, so at this point, what we want to do is we want to familiarize ourselves with how this alternator is wired. So we're going to go to wiring schematics. So we're going to look at the wiring diagram. So let's go to service information and look at the charging system wiring diagram. Alright, so here is the wiring diagram for our charging system. So let's scroll down. So let's find the alternator on this wiring diagram first. Alright, so here is the alternator. Okay, so the alternator has an electrical connector that has 4 wires. Okay, there is this black wire with a yellow tracer, and then this white wire with the blue tracer, and then this white wire with the green tracer, and then this white wire with the red tracer, and then this black wire over here. So if you see this wire, it says B. If you look closely here, it says B. So this means this is the B positive terminal on the alternator. And if we follow this wire, if we follow it, this one, if we follow this wire, we will see that it goes to a fuse, I believe. Hold on. My fingers are too big. I'm trying to scroll down just gently, but it's like skipping pages. Alright, so we were right here. Okay, so we want to follow this wire over here. If we follow this wire, so this, if you follow it, you'll see that it goes to a fuse, a big fuse on the underhood fuse box. Okay, so there should be power at this B positive terminal of the alternator, like we all know. And then there should be an ignition power. So it says it right over there, IG, so ignition power. And if you follow this wire, it goes to a fuse somewhere up here. Okay, so this wire goes to a fuse, and this fuse is in the under dash fuse panel. Okay, so that's good to know. Let's go back down to the alternator. All right, so this is pretty straightforward and easy to do. The first thing we're going to do is we're going to check for power on these 2 wires. We're going to get to the alternator. We're going to check for power at this wire and then this one. We're also going to do a voltage drop test on these 2 wires. And then we're going to do a voltage drop test on the negative side of the alternator, because if you have excessive resistance on this wire or on the alternator body itself, the alternator is not going to work properly. Okay, so we have to make sure there's good power getting to the alternator, there's good power on this ignition wire, and the ground on the alternator case itself is good. And then the last step will be checking these 3 wires that come from the computer. As you can see here, it says powertrain. So we're gonna back probe these three wires at the alternator connector and start the engine to see what kind of signals we have here. If we have some type of voltage or pulse width modulated signal at the alternator here, that will tell us that the wiring is good. So basically, because whatever voltage we're going to have on these wires or whatever signal is going to be coming from the computer. So if we have any voltages here or any pulse width modulated signal, that will mean it's coming from the computer, thus telling us the integrity of the wire. So it means the wire from the computer to the alternator is good. So once we verify all of that, the next step will be replacing the alternator. And I'm sure after we replace the alternator, this problem will be fixed. Okay, so I'm pretty sure that's what it is. This is hopefully going to be a quick and easy one. Let's go under the hood and do some tests at the alternator. Alright guys, so I'm going to show you what I did off camera before we test the wiring of the alternator. So I pushed this radiator fan up, as you can see. So I had to push the radiator fan up so I could get access to the wires of the alternator. So I disconnected the electrical connector of the alternator wiring. So I'm back probing these 4 wires. 3 of these wires are coming from the computer, and then the other wire is coming from the fuse box inside the vehicle. Okay, so after back probing all these wires, we're gonna reconnect this electrical connector. Okay, so we're gonna monitor the signals coming from the computer on the lab scope. If all the signals are there, if we have power on the other wire, then the next step will be doing a voltage drop test on the negative side of the alternator, then the positive side of the alternator. If there's power over here at this B positive terminal of the alternator, then the problem will just be the alternator itself. And the belt actually is pretty tensioned, so the belt looks good. So now I'm going to push this fan back down. I'm not gonna put it back on, but I'm just gonna position it down there because we're gonna have to start the engine. Actually, before we start the engine, let's test our battery first. Let's make sure our battery is good, and then we will go back to testing the alternator. Let me grab a multimeter so we can test the battery. So we're gonna set our multimeter on the voltage scale. So a good battery should have 12.6 volts. So let's connect the positive terminal on the positive lead on the B positive terminal of the battery, and then our negative is gonna go to the black terminal of the battery, so negative to negative. So hold on. So right there, as you can see, we are reading 12.95 volts. Okay, so this is good. The battery is most likely good. So now, since we already got our alternator back probed, so everything on the alternator is back probed, so now I'm gonna go inside the vehicle and start the engine. With the engine running, we will monitor the signals going to the alternator on the lab scope. So now I'm gonna go inside the vehicle and start the engine. So before we start the engine, let's set up our lab scope first. So we're gonna turn on all the channels on the lab scope. Okay, so we are on the voltage scale, so that's good. Okay, so now I'm gonna go inside the vehicle and start the engine. Alright, so I got the key on. So let's go back to our lab scope and see. So with the key on, we have 2 traces that are reading system voltage. Okay, we have the yellow trace and the green trace, that's reading system voltage, and then the blue trace is reading 0.07, and then the red trace has 0.15 volts. So one of them is gonna be coming from that fuse, okay? So that's good because there are two that have power, so the fuse is good, and the other voltage that we see on these other three traces is coming from the computer. This already tells me that the wiring from the computer to the alternator is good. So now let's go inside the vehicle and start the engine to see if there will be any type of activity here on the screen. So I'm gonna go inside the vehicle and start the engine. Alright, so as you can hear, the engine is running. So now let's go to our lab scope. So right here we have 11.96 volts on the yellow trace and same voltage on the green trace, and we have 0.12 volts on the blue trace and 0.15 volts on the red trace. So there's no activity here on the screen, okay? But these voltages that we see are coming from the computer. Okay, so this tells me that the computer is good, the wiring is good, so the problem is the alternator. But before we condemn the alternator, let's do a voltage drop test on the power side of the alternator and the ground side of the alternator. If there's no voltage drops, then we will go ahead and replace the alternator. So now with the engine running, I wanna check the voltage here at the battery. So let's see what we got. I'm pretty sure our voltage is now dropping. So right there, with the engine running, we have 12.20 volts at the battery. Our voltage should be 14 volts or 14.5 volts with the engine running. And I'm pretty sure right now, if I turn the accessories on, our voltage will drop even more, okay? So this alternator is defective. So now one test we want to do before we replace the alternator is I want to do a voltage drop test on the alternator. If the voltage drop test checks out okay, we will go ahead and replace the alternator. Let me turn off the engine and grab the test leads for the voltage drop test we're gonna do, and then I'll bring you guys back up. So this is a problem, guys. This charging system is defective. With the engine running, we shouldn't have 12 volts. We should have 14.5 or 14 volts with the engine running. Okay, so I'll grab those test leads and then I'll bring you guys back up. Alright, so we're now gonna do a voltage drop test. So what I'm doing is we're gonna use a multimeter to do our voltage drop test. So right now we're doing the voltage drop test on the positive side of the alternator. So what I'm doing is one of my test leads is going to battery positive. Okay, so one lead on the multimeter is going to battery positive, and then the other lead is going to the B positive terminal of the alternator. So right there. Okay, so right now we are reading 003.5 millivolt, so which is good. The rule of thumb here is you don't want anything over 0.5 volts on either the negative or the positive side of the alternator. So now I'm gonna go inside the vehicle and start the engine, because you have to do this test with the engine running. Okay, there has to be current flow, but since the alternator is bad, I'm pretty sure there's no current flow. So let's start the engine and see what kind of reading we're gonna have on the multimeter. Alright, so the engine is running and our multimeter is showing 0.63 millivolts. Okay, so this is good, guys. There is no voltage drops on the positive side of the alternator. So now I'm gonna switch this to the negative, okay, negative terminal of the battery. And right now, as you can see, we are reading battery voltage but with the negative sign because we just switched the leads. So now what I'm going to do is I'm going to move this lead to the ground of the alternator. Okay, so right there I just touched the ground of the alternator. So right now one lead of the alternator is going to the alternator ground, and then the other lead is going to battery negative. Okay, so right now we are reading minus 136.7 millivolts. Okay, and this is good, guys. Okay, so basically 138 millivolts, so which is good, which is definitely within spec. So this is good. There's no voltage drops at the alternator. The problem is the alternator itself. So we're gonna go ahead and replace this alternator. So if we look at our lab scope here once again, you'll see that we have battery voltage at the alternator. Okay, and then these other three traces, so the green trace, the blue trace, and the red trace, all this voltage you see is coming from the computer. Okay, so if I show you on the diagram once again, so we are back probing these these 4 wires. So one has got power, and then the other one also has power. So if you have power on this wire, it means it's coming from the computer. And then the other two have, let's go back to the lab scope, and you'll see, so the other two wires over here have 0.14 and 0.19 volt. So that voltage that you see is coming from the ECM. Okay, one has power, one has 0.14, and the other one has 0.19. So those voltages are coming from the computer, so which tells me that the wiring from the computer to the alternator is good. So the problem is the alternator. So I'm gonna turn off the engine so we can replace the alternator. Alright guys, so I turned off the engine. I'm going to get my multimeter out of the way. So let's remove this multimeter. So our wiring is good. The problem is the alternator. So I'm gonna replace this alternator. Replacing this alternator is really easy and really straightforward. I actually have a similar video on a Honda Odyssey. I think the title of the video is battery light on the dash on the Honda Odyssey. So if you want to see how to remove and replace the alternator on this type of vehicle, it's the same engine size, it's pretty much the same process. So go watch that video and you will see how to remove and replace the alternator on this vehicle. So I'm not going to film the process of removing and replacing the alternator. So I'm going to get this alternator replaced, and then I'll bring you guys back up so we can do the after repair checks, because I remember when I did that video, I didn't do the after repair checks. I just showed you guys the battery voltage at the battery after the alternator was replaced. We saw 14 volts. But before replacing the alternator, we had 12 volts with the engine running at the battery, telling us that the charging system was defective. After that, I had some questions. Some of you asked me why I didn't do some after repair checks. Some of you wanted to see the signals at the new alternator. I didn't do that, but I'm specifically doing this so that I can show you the after repair signals at the alternator with the alternator replaced. Okay, so it's basically the same thing, but in that video I didn't show you the signals after I replaced the alternator. So I'm gonna get the alternator replaced. I'm gonna leave my test leads over here. I'm not gonna disconnect them. Then I'll bring you guys back up so we can watch the signals that we have at the lab scope with the alternator replaced. We will see if they will look different. Remember, at the lab scope here, we had two traces that had battery voltage. Okay, so two traces. So the first trace So the blue trace, no, the green trace, no, the yellow trace and the green trace had battery voltage with the engine running and the defective alternator still in the vehicle. And then the blue trace had 0.14, I believe, if I'm not mistaken. And then the red trace had 0.12 volts. Okay, so let's replace the alternator. Then we're gonna monitor the signals at these wires again, and then we will wrap up this video. So I'm pretty sure after we replace the alternator, the charging system will be fixed and we will have 14.5 volts or 14 volts at the battery, and then the battery light on the dash will be off at that point. So I'm gonna get the alternator replaced and then I'll bring you guys back up. Alright guys, so I have installed a new alternator. So here is the alternator that I installed. So right there, as you can see, the alternator looks new. So I replaced the alternator and the serpentine belt. Okay, so now we're gonna verify our repair. Remember before, the battery light was remaining on the dash while the engine was running, and also while the engine was running we had 12 volts at the battery. So if our problem was indeed the alternator, after replacing the old alternator, our voltage should go up. We should have 14 volt or 14.5 volts at the battery with the engine running. So now let's go inside the vehicle and start the engine so we can verify our repair. Alright, so I'm gonna start the engine. So right there, as you can hear, the engine is running and the battery light remained off. So this is a good sign already. This is good. So with the engine running, the battery light is not on, so that's good. So now let's go under the hood and check our voltage at the battery, and then we're also gonna look at the lab scope to see what kind of signals we're gonna have on the lab scope. So now let's go under the hood. Alright, so we're gonna check the voltage at the battery first. So let's get the alternator the multimeter connected to the battery. So let's turn the multimeter on. So right there, as you can see, with the engine running, we have 14.48 volts at the battery. So this is good. This means our charging system is now working. So 14.48 volts is good to charge the battery and also supply enough power to the electrical system on the vehicle. Okay, so now I'm going to go inside the vehicle and turn on the headlights. So these are the running lights. I'm gonna turn on the headlights with the headlights on. So we're basically gonna load the charging system. With the headlights on, our voltage shouldn't go below 13.5 volts, or ideally 13 volts. Okay, so now let's go inside the vehicle and turn on the headlights. So I'm gonna turn on the headlights really quickly. So right there we got our headlights turned on. So as you can see, the headlights are on. So with the headlights turned on, actually the voltage didn't change. It actually went up a little, 14.50 volts. So the voltage didn't change, so that's good. Okay, so this is really good. Now let's turn off our headlights. So this is fixed, guys. The charging system is now working. So now let's look at the lab scope. Remember before we only had flat lines on the lab scope. Let's look at the lab scope screen and see what kind of signals we're gonna see on the lab scope. So here is the lab scope screen. Actually, let me show you the connector. We're still back probing the wires at the alternator electrical connector. Okay, so as you can see, we now have some type of pulse width modulated signal here. So remember before we had about 12 volts on the yellow trace, and we also had about 12 volts on the green trace, but now we have 2.60 volts on the yellow trace and 3.27 volts on the green trace, and we have 4.80 volts on the blue trace, and then 14.11 volts on the red trace. So the red trace is actually the power supply wire that's coming from the fuse in the vehicle. Okay, and right now we have a pulse width modulated signal on this green trace. Okay, so this is fixed, guys. This is fixed. So this is the type of signal you should see on a good charging system on a Honda Pilot. Now you might have a question about why we didn't have this before. Well, this pulse width modulated signal is being caused by the regulator inside the alternator. So this voltage is actually being pulled to ground by the regulator inside the alternator, because remember before we didn't have this. We only had two flat lines, okay, on the lab scope screen. So we didn't have this because the regulator inside the old alternator is defective, so it wasn't doing its job. Let me turn these channels off. So as you can see, we have a nice, you know, kind of looks like a square wave, but it's not. It is a pulse width modulated signal. Okay, so this is good, guys. This is to those of you that use lab scopes, this is a good looking pattern. Okay, this is what you should see on a good charging system. I'm gonna leave this right over here. Now we're gonna turn off the engine so we can wrap up this video. So right there we have 14.48 volts at the battery, so that's good. Let's turn off the engine so we can wrap up this video. So this is fixed, guys. As you can see, the battery light is off, so that's good. So let me turn off the engine. Alright guys, so I'm gonna leave this right over here. This vehicle is fixed. The problem on this vehicle was a defective alternator. So now the charging system is working. The battery light is no longer remaining on the dash while the engine is running. So to those of you that wanted to see the process of replacing the alternator, I recommend you watch my video on a Honda Odyssey that I did a couple weeks ago. The title of the video is "Battery Light Remains On While the Engine is Running," and it's basically the same process. That vehicle also has a 3.5 liter engine, so it's the same. So if you wanted to see how to remove and replace an alternator, I recommend you watch that video. So this is fixed, guys. You saw before when we first started working on this vehicle, we had 12 volts at the battery with the engine running. After replacing the alternator, we now have 14.50 volts at the battery. So which tells me that the charging system is now working. And we saw on the lab scope screen, we now have a pulse width modulated signal that we didn't have before. So this is fixed, guys. I hope you liked the video. If you do like the video, give it a thumbs up. If you don't, give it a thumb down. But if you do, you gotta tell me why so we can make better videos in the future. If you have any comments, questions, criticism, leave them in the comment box. Thanks for watching, guys. See you next time.